Hello, and welcome to Durham College's Student Academic Learning Services video on homeostasis. By the end of this video, learners will be able to define homeostasis, list examples of homeostatic variables in the human body, define the major parts of a homeostatic system, recognize homeostatic systems as a cycle, and describe an example of a homeostatic system. What does homeostasis mean? If we break down this word, we can see that homeo means the same, and stasis means to stay. So in the end, the definition of homeostasis is that it means to stay the same. There are many variables that the human body tries to keep the same. These homeostatic variables include temperature. The normal range for humans is between 36.4 and 37.6 degrees Celsius. pH, with a normal range of 7.35 to 7.45. Blood clotting factors. Without injury, no clotting factor is activated, and therefore no clots are formed. And there are a variety of other variables with various normal ranges. What are the parts of the homeostatic system? The first part is a stimulus. This is the external or internal effect on the body. For example, it might be cold or heat. The second is the receptor. This is the part of the body that senses the change on or in the body. The control center. This is what processes information from the receptors. The set point. This is the standard or normal range that the control center compares to. And finally, the effector, which causes changes on or in the body. The parts of the homeostatic system work in the following fashion. Some internal or external stimulus affect some receptors. Those receptors send information to the control center. The control center then compares those changes to the set point. The control center then sends information out to the effectors, which can then cause a change. And then this continues as a cycle in order to create balance. Let's look at a specific example of homeostasis, in this case body temperature. In humans, the set point for body temperature is near 37 degrees Celsius. So, if there's a stimulus that causes body temperature to rise, receptors, in this case temperature sensing nerves, will receive that information and send it to the control center, the brain. The brain then notes that the body temperature is above the set point, and then causes an effect through the effector, in this case skin, causing blood vessels to dilate and sweat to be produced, which will cause a decrease in body temperature. Another stimulus might be a body temperature dropping. This would have an effect on receptors, the same temperature sensing nerves, which would then tell the brain, and the brain would note that the body temperature is below the set point. It would then cause an effect on the skin and muscles, causing blood vessels to constrict, the person to shiver, and metabolic rates to increase. This will cause an increase in the body temperature. By the end of this video, learners should be able to define homeostasis, list examples of homeostatic variables in the human body, define the major parts of a homeostatic system, recognize homeostatic systems as a cycle, and describe an example of a homeostatic system. Still confused? Have more questions? Please feel free to contact us to make an appointment with a SALS science specialist. You can reach us by phone at 905-721-2000, extension 2491, or by email at sals@durhamcollege.ca. Please help us gather feedback to improve the service we provide in student academic learning services. If you are viewing this presentation online, please email us any suggestions you have to improve the experience at sals@durhamcollege.ca.